For conceptual analysis method, let's say how to draw a bending moment diagram directly. AB part is a cantilever part. Q is equal to 0. So the bending moment diagram is a diagonal line, upper side in tension. So we could draw such a diagonal line. MB is equal to QL times L, that's QL square. For BCD part, Q is equal to 0. That means the bending moment diagram is also a diagonal line. MC is equal to 0. So we could connect MB and MC and elongate the line to section D. MD could be calculated according to the relationship of the two triangles. So MD is equal to 2QL square. For the FH part, the bending moment diagram is a polyline. MJ is equal to half of QL square. Then let's say for the EFJ part, the Q is equal to 0. So the bending moment diagram is also a diagonal line. That means we could elongate FJ line to the section E. According to the relationship of these two triangles, we could calculate ME. That's equal to QL square. For DE part, we could use superposition method. Connect MD and ME by such a dashed line and then superimpose a parabola. The ordinate here is 2QL square. That's all for the bending moment diagrams construction. Now let's say how to draw shear force diagrams according to bending moment diagram. For AB part, the bending moment diagram is a diagonal line. The slope is equal to QL square over L. So that's positive? No, that's negative QL, right? So for the AB part, shear force diagram is a horizontal line. The value is negative QL. For BCD part, the slope of bending moment diagram is QL square plus 2QL square over 3L. So that's positive QL, a horizontal line. For the JH part, the slope of bending moment diagram is half of QL square over L, so that's negative half of QL. For EFJ part, the slope of bending moment diagram is QL square plus half of QL square over 3L. So that's positive half of QL. For DE part, the bending moment diagram is such a dashed line superimpose a parabola. So we could also use superposition method to construct the shear force diagram. We could draw a dashed line corresponding to the slope of this dashed line of bending moment diagram. The slope is QL square plus 2QL square over 4L. So that's negative 3QL over 4. Then we take this dashed line as a baseline to superimpose a diagonal line because Q is a constant for the DE part. Here, this value here is Q times 4L over 2. That's 2QL. So that's 2QL minus 3QL over 4. The value here is 5QL over 4. According to superposition method, this value here is equal to this part, 2QL, plus this part is 3QL over 4. So totally, that's 11QL over 4. This is the shear force diagram corresponding to the bending moment diagram. According to the shear force diagram, we could know the support reactions. For support B here, the Chapt value here is negative QL, positive QL, so the reaction at B is upward to QL. For the support reaction at D in vertical direction, according to the shear force diagram, the value here, the jump value here is 5QL over 4 minus QL, so that's upward a quarter of QL. For support E, the vertical reaction here is equal to the jump value of the shear force diagram here. That's half of QL plus 11 QL over 4, so that's upward 13 QL over 4. For support H, the reaction is equal to the value half of QL upward. About the solution steps for calculation of the internal forces of determinate multispan B. Firstly, we draw the graph of relationship to distinguish which part is mean portion and which part is subsidiary portion. Then, we solve the reactions from the accessory portion and transmit them to the fundamental portion. The third step is to construct the moment diagrams for each part using superposition method segment by segment. The fourth step is to construct the shear force diagram according to bending moment diagram. At last, we should check the shear force diagram using reactions. Also, we could analyze the geometric construction of the beam firstly. The second step, determine the moment at control sections, and then construct the moment diagrams for each part using superposition method segment by segment. The fourth step is to construct the shear force diagram according to the bending moment diagram. Then determine the reactions according to shear force diagram. At last, check the reactions by equilibrium equations. That's all for today. Thank you for your attention.